Good afternoon or good day to everyone. I hope we are all doing well. Welcome to today's video. We are going to look at Introduction to Multism, or basically how to use Multism for circuit design. So we'll start off by understanding the interface we have here. When you look at this section, this is what we call the menu bar. And then here, which is also part of the menu bar, is what we call the tools bar. And then here you would find the component toolbar, which comprises of several components. So you would see, for instance, when I select this, you would see several components, power sources, signal voltage sources, and all that. Now, before we proceed, what is Multism? Multism is basically an electronic workbench that allows for the design and simulation of circuits. Multism is designed by Texas Instruments. So kindly take note of that. And so what we are going to be doing basically here is to try and identify where we can find components, build some basic circuits, and simulate them as well. So for this introductory lecture, let's see how we can find components, from this software. So anytime you want to find components, the first thing you do is to come to place, and then you would have components. But before we go to finding components, let's make this easy so that you can follow. So upon opening Multism for the first time, you would see that the name of your default interface is labeled Design 1, which you would see here as well. So what we can do is to change the name. So you go to File, and then you can save as and choose wherever you want to save it. So I have a Multisym circuit design suite folder, so I would want to save it as Linus or Antonio. So once I have done that, the name should change to Antonio, like you can see here. Now, assuming I am opening this for the first time, when I close this window here, I would see something like this. So if I'm going to create a new file, I could just select Create New and then select New, and New would open a new file for me. So it asks me to choose a blank template or go to Install Templates. There are some installed templates there, and if I have designed some templates of my own, I would also choose from that. But in this case, we could just use the blank template and then create a new one. And then I would have this with the so you take note of that. Yes. So with this, what we can also do is that, assuming we don't have to create a new one, and we need to open one that has already been installed, then you just go to the menu, go to File, and then go to Open. Now, Open would give you the option to choose what you have already saved. So in this case, I'm selecting what I had already saved, which is Antonio, and this would open. So this is what we'll see. All right. So now we have seen how to create a new schematic, how to save a new schematic, and also how to open a new schematic. So let's proceed from here. So here, what we'll do is that at this point, we would want to find components and see how we can design some simple circuits. So for instance, if I am looking for components, there are several ways to go about it. When I come here and I select components, this will open a toolbar, a components toolbar for me, where I would see components grouped into databases. But very often we prefer to use the master database, and then they are further grouped into or classified into groups. So you would see sources, basics, diodes, transistors, analog, TTL, CMOS, advanced peripherals, mixed digital, mixed indicators, power, miscellaneous, RF, which is radio frequency, electromechanical connectors, and then NI components. So after the groups, you would also see families. So for instance, you select sources, you see different families of sources: power sources, signal voltage sources, signal current sources, controlled voltage sources, controlled current sources, controlled function blocks, and then digital sources. Okay, now you would also see under basics, you would see several components or families under basics: virtual, rated virtual, RPAC, resistors, capacitors, inductors, and all that. So here, what I would entreat you to do is that once you're familiar with this components database, you can take your time and go through one by one, from group to group and from family to family, to try and understand what components are there under each and every group or each and every family. So in this case, we want to build a simple resistive circuit. But before that, when you come to place as well, you are not able to only place components. You can place probes, that is current, voltage, power, differential voltage, voltage and current, voltage reference, digital. You can also place junctions, wires, bars, connectors, just name them. Okay, all right. So one way is to go through using the place, and then you select components, and then for instance, if I need resistors, I will just select resistor. Do not worry about the value of the resistor. You can always change the resistor value at any point in time. So in this case, if it is a resistor I'm looking for, once I select OK, you would see that the resistor has been added to the cursor. Okay, so once I click an open space, my resistor would be placed, and then the box would open again. If I want more resistors, I can add another resistor. Now, another way of going about it, which is the easiest way, is that at this components toolbar, you would see basic or place basic. Once you select this, it leads you to the same place, and then you can place another component. Okay, now let's say I'm building a series parallel circuit. So in this case, I have basically 3 resistors, resistor 1, 2, 3, or let's start with a series circuit first. So once I select and delete, I can always do that. So in this case, if I can rotate this component as I wish with 90 degrees clockwise rotation, and then if it is a DC circuit, when I come to place power sources, I can just go to power sources and then select DC power, and then I'll get a battery, and then I put my battery here. Now, how do I connect these components? Once I put my cursor here, I would hold and drag and then connect, and then I'll get a connection. And then the same thing, this will give me another one, and this side as well as this side. Now there is something missing here. The circuit is not grounded, so we come back to sources and then we look for a ground, and then we ground the circuit. So in this case, the circuit is now grounded. Now let's say we want to change the value of the component. Once we click on this, the value is 1K. If we want to make it 10K, all we need to do is type 10 and then K. The ohm unit is always attached already. The system understands that, and the system understands M as milli, capital M as mega, U as micro, K as kilo, etc. And then you can also change the display label or the label from R1 to R2. But normally when you're doing that, you make sure you don't have an existing label to which you are changing to. Okay, so this has been changed to 10K. You see that has happened. Now this circuit is complete. Now if we want to simulate this circuit, it is very simple. What we would need to do is to use the run or the F5 to run the circuit. But if we run the circuit at this stage, what would we be looking for? We probably may be looking for current that is going through the circuit and voltage drop across the various components. So if it is current, then we can say that let's place a probe that is a current probe here to try and measure the current for us. And now if we want to know the voltage drop across each and every component, it means we would have to put a multimeter on or across each and every one of the components. So in this case, when you come to this side, on the right hand side, you see instruments toolbar, you see multimeter, function generator, you would see wattmeter, oscilloscope, you would see 4-channel oscilloscope, you would see basic plotter, you would see frequency counter, you would also see word generator, you would see logic converter, etc., etc. So basically this is just a simple series circuit. So let's see if we can measure the voltage across each and every one of these resistors. So we place one here, we can just select this, copy, and then paste another one here. So we have two multimeters. There is one connected across resistor 1, and then another one is also connected across resistor 2. Now, since this is a multimeter, it means the multimeter can measure current, voltage, and it can also measure power, resistance as well. So once you double click on this, you are able to find or open the interface for the first multimeter, and then this will also give us the interface for the second multimeter. Now we're dealing with DC because our supply is DC. We would be having what? The supply as DC. What are we measuring? We're measuring voltage, so we select V. Okay, if it were current, we'll select A. If it were resistance or power, we'll select these ones respectively. So in this case, you would find when we simulate or when we run this, we would see that at the end of the day, our circuit is having a certain amount of voltage drop across each and every one of the components. And then, you know, in a series circuit, the sum of the voltages that leave the source are equal to the voltage at the source. Similarly, you would also see that the current that is going through the system is 1.09 milliamperes of current. So basically, this is just an introduction to the Multisym software. Take your time and explore these menus, and then get yourself acquainted with the various components in the menu. We would go ahead later on to look at the various ways of simulating different kinds of circuits from time to time. So in our next video, we'll progress from here. Thank you for your time.